Okay, welcome back to the Caribou Data Science channel, an impromptu session, which should be no surprise. These do happen with fairly regularity. Let me just make sure I am live here real quick. This is actually a redo. The first one I recorded last night, Friday night. Well, the trouble is, it wasn't watchable. I got the dreaded stream 52 years ago today error message, which means it's basically which means it can't be viewed by anybody. Let's go up here, pop up chat. Let's minimize this. Let's do this. Let's try expanding this across here and moving this up to. No, that isn't going to work, is it? That's. I thought it'd be kind of interesting to actually have the have the chat at the top, but that doesn't really work right, does it? Okay. There we go. Okay, so here we are. So we got some data here. It's U.S. tuberculosis data, 1900 to 1923. I'll just mention that a brief history of tuberculosis in the U.S. is begin with. The first treatment, antibiotic treatment, began in 1943 with streptomycin. The variations of streptomycin, I believe, are still being used today for treatment. But what they quickly realized is that the disease developed a resistance very rapidly. So they then moved on to a cocktail or a series of drugs. The next one being INH, and it says this became the backbone of TB therapy, and it was used in combination with streptomycin and other drugs to create the disease. Okay. Now, the question now we get back to the question of the title. What is the Hopemont Yodel? Well, my dad said when he was a kid, my dad was born in 1925, he said when he was a kid, if someone coughed, you would say you have the Hopemont Yodel. Of course, Hopemont or Hope Mountain, okay, was the first tuberculosis sanitarium or hospital built in West Virginia. It went into operation in 1912, and then at that time, approximately 1,000 people a year died in West Virginia from tuberculosis a year. Okay. And of course, prior to 1912, the treatment was a sanitarium, which is essentially to isolate the person with tuberculosis from the general population. And the treatment consisted of lots of fresh air and exercises. Okay. Now let's take a look at some code here. You all recognize that I'd like to say the usual suspects: tidyverse, lubridate, read Excel, and janitor. So we're gonna first load the some data. Then we're going to use a summary function to give us the min, the max, the median, and the first and third quartiles. Okay. Now, as you notice, we are using Doom Emacs and Quattro to create our final document, and then we move down. We do a histogram and a box plot. Before we get started here, let's come over here. Let's see if we can create something here. Use I want to pull out I also want to create a decade Do you want the decade column to show the starting date? Okay, good. So let's go over here. Let's copy this. Let's just go ahead and all right. Okay. Decade. Okay. Uh, let's come down here. First we're going to do a histogram and a box plot. So what we're going to do here is you want to come over here now. Let's see if this works. So what we want to do, we want to try to create a separate plot based on decade, okay? Now we could also create decade as a factor also, couldn't we? That can make it more interesting to plot. This can make it. This can make the date column a little more interesting. Okay. And then we're going to come down here. We're going to try to create an individual plot, a single plot with individual box plots and histograms for each decade, okay? Then we're going to do a straight plot, year and so on. We're going to plot a straight line plot, year by year of deaths, covered also with the geom plot. Then we're going to import the second table, which has it broken up into two age groups: under 45 years of age and older and above 45 years of age. Now this data only goes, I think, to maybe we'll find out. Okay. Then we do age-based deaths, right? Under 45, over 45. You don't need this. Let me come down here, and this code comes from the good folks at ChatGPT. And what it does is they create a pivot longer. Okay, names, population. Interested in what population means. Okay, this isn't actually population, this is deaths. Yeah. Okay. Yes. Year. Then what this does is, this creates an area plot, okay, with under 45 and over 45, by name, age group, labels, so forth. This comes down here. Oh, we actually create an area plot up here too, don't we? So we can say alpha let's go up here. Equals 0.8. So this will give us something similar. You know what let's do? Since we got another column already, we got area plot, right? Let's go and try to create this as a column plot. See what happens. Okay. So now let's come over here. Let's see if this will actually run. Now, as you see, this for the first part of the 20th century, this really was a scourge. Okay, names must be unique. Okay. Let's take a look at this. Let's go over here. Let's delete this. See if this works. Use a P to paste to the end. Names are duplicated. numeric or continuous. That's interesting. Okay, let's come up here, and let's just delete all this for the time being. Okay, because we are actually kind of doing it someplace else already, aren't we? Okay, let's see if this works. Okay, good. Let's go over here now. TBDefs here. Okay. Oh, this is nice. Huh. Okay. So this now we have the colors for you, so you can see the biggest numbers. Well, the defs. So interesting. And now, okay, now this is also interesting. This is kind of what we're looking for. You can see that the green-ish is either 19. This is 1930. Okay. This is 1950. Now this is interesting. I'm not sure it's necessarily helpful. Okay. Now we did have a gap right here. Okay. Let's come back over here. And age. Let's see here. What do we want to do? Let's come back up here. Because the trouble is that we actually have. I wonder what this would look like then. So we'll put a scatter plot over top of it. Well, let's do this. Okay. Over top of column plot. How about that? But it's also Now by putting the hash mark there, okay, what it does, it's going to create a table of contents entry. So let's go over here then. So we're going to say ggpot / tb gom l equals alright. Because we already looked at deaths by decade above, right? Let's come back over here, take a look at some of these column names. Under 25. So you can see the year goes from 1900 to 1950 here, okay? Let's see, equals, okay. All right. And let's make this one, because what you want to see is, no, the under 45 has the largest group of so this will give us and we can come back up here also. Let's come back up here and do a little bit of funky stuff with the let's do what we're going to do is we're going to create a separate box plot equals for each decade. By using the facet wrap tilde comma equals 3. Okay. I'm not sure if that's going to work. Let's come back down here now. So now we come down here. We got the plot for the under 45 and over 45 deaths. What you're going to see is in the beginning up until the middle, like almost the 50s or so, you're going to see that the most deaths from tuberculosis were under the age of 45 if this code runs. Okay. So let's save this, and let's see what happens over here. So far it's couldn't find geome box plot. Come back over here. Quattro RNDR. Oh, good. Good. No error message. That's also a good sign in it. I'll come back over here then. So, we got our histograms. We got our histogram by year, right? And you can see most of the deaths. The majority of the bigger numbers were actually early on. Okay, so this is good, right? And the majority of the bigger deaths again were in the early years. Now we got a box plot, okay, for each decade. All right. Let me come down here. This is sort of interesting. I'm not quite sure what this represents. What do we do here? Warning. Now you can see the deaths by decade. Okay. Okay, we got it backwards there. So a couple of things we want to do over here. Come back over here. We want to put the alpha on the bottom one. So that works. That should work. Come back up here to what? Deaths by decade. So this works good. Columns, year deaths. Then I wanted to put a line over top of that. Well, if we don't align it, let's just. That was an interesting plot one. We had the line thickness varying based on the number of deaths. That's interesting. All right, let's come back over here now. 31 minutes. Everything ran, good. We come back down here now. We've already checked that out. You know what could be interesting is instead of a histogram, okay, not quite what I wanted, but nonetheless, you can see here the number of deaths by decades. Okay. There is a gap here. Now here's the death by decades. You can see the biggest decades were the 30s, and they peaked actually in the 40s, right? And when do we say the first vaccine was distributed? The first vaccine was 1943. Okay, so even though the deaths peaked here, all right, even though the deaths peaked here, we saw a huge decline beginning in the 50s, all right? A continued increase from 1900 to 1945, all right? Okay, so this still isn't right, is it? Let's see. So this one down here still doesn't look right, does it? Area. Let's just get rid of. First, let's come up here for decades, and the line isn't really. Let's just go with a straight line plot here. And let's come back up here, and let's change this to a histogram. Let's see if this looks more interesting. Histogram. And let's do one more thing here. Let's come over here. Equals free y. All right. So we need to add some more columns here. Okay, come down here and let's do this. Let's remove the let's get rid of minus year. let's only look at the two. Let's don't look at all the columns here either. E. Let's say des, comma, under 45, comma, okay, so we don't really need the years and stuff like that, do we? Let's come back over here and let's see what happened. This is interesting. I have no idea what this is down here. That's interesting. Huh. That's interesting. Okay. Let's just get rid of this alpha down here since I'm still not looking right. All right. Let's come back and run this again. And if this runs, this will be it for this evening. Confine function summary. So it's near the top. Got an extra. Okay, good. Quattro, rendo. Oh man, selected column does not exist. Decade. Okay. Now, is there a good reason to use Emacs rather than RStudio or a Positron or VS Code? No, not really. Not really. But you know what? It's kind of fun to just see what we can actually do with Emacs sometimes. Okay, and again, because we're using Quattro, as you can see, it's just a plain text file with a YAML heading, and telling it what to do. Okay. So now you can see we got a few table of contents up there. Defs, again, minimum is 470, maximum is 97,000, first quartile is 930, third quartile is 19,000, so there's a big spread. So this means that 50% of the values, okay, are between 930 and 19,000. The median is 3,100. The mean, so there's a big difference between the mean and the median also, okay? Here's our box plot. Now you can see our individual histograms. And because we use the y, the scale variable, you can see that the y-axis have different values for different decades, okay? Again, you saw 1950 was the really big year. Okay, this was 50,000 here. Okay, the rest of these were much smaller. So we come over here and take a look at the deaths between 1950 and I still don't like the line plot there for some reason or other. Let me see something here. This is deaths by year. Let's see what happens if we do it this way. Interesting. Now, this keeps happening for some odd reason or other. We could also open up a terminal window and run it that way, okay? Quattro, window. I mean, it's kind of fun to run it in a shell, except for the fact the shell keeps freezing on us, okay? Let's go over here now. Come down here. Here's our plots, our histograms. Okay, what it is, now I remember, what it is, it's done by every 5 years. So it's 1900, 1905, 1910, and so forth. But you can see there wasn't that many reported years prior to 1940. So this is kind of interesting. Well, we had a lot of deaths there. There seems to be a lot of skipped values. Then all of a sudden the numbers start clumping up over here. Oh, you know what it is? I'm using two different date sets. That's what it is. And what happened is, the one date set only used it, from 1900 to 1950 only was every 5 years. All right? But the second date set, from 1950 to 2022, was every year. And you can also see we got a gap here, but you can see the numbers really begin, the numbers actually begin to decline back over here like 1927. But the really big climb began in the 40s. With the addition of the first diseases. And you can look here by decades, okay, and again 1940s was the big one, but the vaccine first became available, what, 1943 or something like that, and by 1950 we were clearly winning. Here's the summary by the deaths again. This is from the second data set. 1900 to 1950, I think it was, under 45, okay, over 45. You can see under 45, there were more deaths, okay, up until a point. And let's come back over here, and oh, shoot. We want to use a fill here. I always get this confused. Because you're filling an area. A collar basically this collars the border of the area, okay? We'll see how this one looks. But the other thing I also like to point out is the code here is very basic code. Okay, it's very basic. There's nothing tricky, no tricky, tidyverse hoops, no tricky plots, just basic plots, histograms, bar plots, line plots. Okay, so let's just take a look here one more time. And at some point over here on 1923, the over 45. Okay, let's do one more thing here. Let's come back over here for over 45. Let's make sure I'm looking at that right, okay? Over 45. So we want to make the over 45, use an alpha for the over 45. Equals 0. Let's see how this works. Okay, let's go over here. That's a little annoying to have that thing constantly throwing that in it. Okay, so let's come back over here. Auto, render, and what this will do is the alpha will allow us to see the crossover, okay, the crossover date, crossover period. Oh man, if I could type, it'd be really helpful, wouldn't it? So what the alpha allows us to do, it'll allow us to see the, if it works, it'll allow us to see the crossover period for the age-based deaths, okay? Okay, good. So what it allows us to do is to see the crossover period, okay? See the crossover period. So in 1920 somewhere, when the under 45 deaths, okay, cross below the over 45 deaths, and that's what you have here, okay? So there you go. There's your brief session today, the redo of the live stream last night. Again, in case you missed the beginning, the title, Hopemont Yodel, goes back to my dad's old child in West Virginia, and and Hopemont was a tuberculosis sanitarium. So when you said, "Oh, you got the Hopemont Yodel," you were saying, "Oh, you got tuberculosis." Okay.